All right. Hello, everyone. Welcome to April 13th, 2022 meeting of SIG Auth. Let's kick it off. We have a few items on the agenda. First off, we have trust anchor sets cap. Ahmed, do you want to take over?
Sure. So I guess basically, as I mentioned last time, this is KEP proposing a new object for holding effectively X509 root certificates for various purposes within the cluster. They could be used by signers when signers have some private roots that need to be distributed to anyone within the cluster, assuming that the signer is not issuing certificates that are backed by WebPK or some other well-known PKI hierarchy. They can also be used. One of the use cases that was suggested for them is, since they are a container for certificates, they can also be used in the webhook and aggregated API server configurations instead of directly embedding certificates in those configurations to make rotation easier. The proposal has two pieces. The first piece is defining the actual trust anchor sets API object and its semantics and how we control access to it using RBAC. And the other is a kubelet projected volume source that allows pushing certificates that are contained in a trust anchor sets object into a pod file system for use by pods. I saw that Mo went through and added some comments. I did have one, I guess maybe follow-on question for Mo about one of his comments, and maybe other people who are in the call. I kind of looked at how RBAC is applied to certificate signing requests, and then I just copy and pasted that into this proposal as how RBAC applies to trust anchor sets. Specifically, there's some special setup where you can write RBAC in terms of the signer name field inside the object rather than just on the name or namespace of the object. And Mo mentioned that that only works for write operations. And I was wondering, is that like a fundamental limitation or can that be enhanced?
Is there any reason
someone might want that? Definitely they should not be globally writable, but I think as most, like that definitely works. Like that's how certificate signing requests work. I'm not sure about the read case.
It is technically harder for reads. So for the additional authorization checks, those are usually performed in admission controls, and there's no admission control for read requests. So it's not technically impossible, but it is
harder. Okay.
Harder.
I'm actually wondering whether we need sort of this second tier of authorization around this. Like if write permissions, it seems like you could just use normal RBAC and say like you can create and update this specific named trust anchor set.
Yeah, so the original version of this proposal had like a kind of crappy little encoding mechanism where you would take your signer name and translate that into a valid Kubernetes resource name, replacing slashes with dashes and dashes with dashes and all kinds
Yeah.
of. But then I read the CSR, like their mechanism, and I was like, oh, well, that lets you just talk about signer names, so that's way better. But I mean, it could go either way.
Yeah, I mean, the signer name part of this is interesting, but we have trust anchor sets for things that aren't signers of CSR objects as well. So, I mean, the kuberoot CA config map in every namespace comes to mind. Like that doesn't correspond to a CSR signer. But if this mechanism had existed and we could project that content into pods, we would have used this instead of a config map in every namespace. So I don't know that I would like 100% pin this to signer name. I think like these are going to, the names of these objects are going to become basically well-known objects, or because they're going to be referenced in pods, right? And
yeah,
so I think like a policy around a well-known object like this actor is allowed to create and modify this trust anchor set. That actually seems like a reasonable RBAC policy to write, which you could just do as an RBAC policy without anything special.
The reason, so I think I agree, and I think maybe that's where we should go with this. I think the reason I ended up here is that originally this proposal was together with the certificate issuance proposal. And in that case, you had one volume and you use the signer name to identify who you want to sign your certificate. And I didn't want to have people also specify another name, which is where you get the root certificates for that signer. I wanted everything to be derived from the signer name, which required programmatically mapping that signer name into a valid Kubernetes resource name. But we could go a way that says, hey, signers, go pick one nice name that is kind of like your signer name and use that to store your know the name of that resource.
I mean, having a mapping of signer name to trust anchor set name and having it be, you know, domain qualified and things like that, and saying we reserve star.kubernetes.io names for holding trust anchor sets for signers and star.kubernetes.io for other uses. Like just making that part of the API definition and say, this is how we're expecting this to be used. If you use a domain name that isn't your own and you get stomped on when you install an add-on from that domain, like you got sort of what you asked for.
Okay.
So having a mapping and saying like, this is how you should translate a signer name into a trust anchor set name makes sense to me, but I probably wouldn't bake firsthand knowledge of that into the trust anchor set.
Okay.
As a counterpoint, I don't really disagree with anything you said, Jordan, but as just the other side of it, one of the things I kind of liked about this approach was that you didn't gain like well-known names. It was like, if I understood the design correctly, it was when you asked for this stuff to be mounted, you were asking for a particular signer name to be mounted into your pod. And to me, that seemed more like a nice pointer to what you were asking, right? And it might be backed by one or many trust anchor objects, and Kubelet's going to hide that for you. I mean, I don't know if that maybe is not helpful, but it was just the sort of like, I mean, I guess we have a lot of things in the Kubernetes API that just have well-known names, and maybe that's okay. Having another thing that's basically based on well-known names might be just fine.
Having multiple API objects that could be providing content for what is effectively a well-known name, like whether the well-known name is actually the object name or whether it's a field inside the object. Like the level, I'm not sure what the level of indirection is getting us. And in some ways, I feel like it makes things weirder. Like if I have locked down kuberoot CA trust anchor set,
And someone
but
just adds
like
another
someone
one.
else has the ability to write their own thing, and they can be like, hey, this is the kuberoot CA trust anchor set too. And it gets aggregated together. Like that sort of freaks me out a little bit.
Yeah, I can see that. Now that I think about it, it sounds like a NIST feature. It kind of sounds like how role aggregation can go very wrong if you do it wrong. Yeah, so I could buy that. I think that's.
I think the main bugbear here is the slash that can be in the signer name, and I'm guessing it ranges from basically impossible that we could have a Kubernetes resource name that has a slash inside it, just for this resource type.
Yeah, that's impossible.
Yeah, let's not try to change the static validation for the API server for one resource, because that's one of the few checks it does for everything.
Okay, then I'll update this to re-add that sort of little
Mapping.
hey, this is how you're supposed to translate your signer name to a resource name, and I'll remove the special RBAC stuff.
Cool.
Well, while we're talking about this, I can see my questions on there, which is, does the kubelet validate if the pod service account is allowed to read the trunks anchor sets that's asking for? Is that like part of the check? Or can you just effectively use the kubelet's permission to read data that you technically can't read?
I thought about this and I went back and forth on it. I think where I settled eventually was this just happens in terms of kubelet.
Does the
Which I
kubelet
think
make
is
those checks for secrets and or config maps?
Does the what?
Does the kubelet validate whether the service account a pod is running as can read a secret or read a config map before mounting it?
No.
Though those are namespaced to the same namespace as the pod. So whoever wrote the pod,
Right.
like that, being able to author a pod or something that produces a pod, like a deployment or something, like that implicitly grants access to config maps and secrets in that namespace. So it's namespace local, which is why we say over and over, like namespaces are the boundary for permissions like that.
Rita, I see that Tim has a link in the chat. I don't know if you wanted to open it. I don't know what that is, but hopefully we're not being rickrolled.
Yeah, this was just since you mentioned RBAC on field names, kind of a document that Joe sent out earlier, and I just wanted to kind of cross-link the discussion that we had at the last SIG Auth meeting about RBAC conditions and using cell for that and node authorization. Didn't mean to derail the current discussion, but
what is CEL?
Common expression language. It's a limited. I don't think it's Turing complete. I don't think it has enough loops or something.
Yeah, it's bounded execution time, I think.
So it's type checked, resource constrained, non-Turing complete expression evaluation language. And custom resource definitions are adding support for expressing validation inline in CRDs that goes beyond what you can specify with OpenAPI schema validation and removes the need for some categories of admission webhooks.
Is there a I feel like that needs to be linked at first use there in that document, but
Oh, cell.
Yeah.
Yeah.
All right. So Ahmed, I think you have pretty clear next steps, right?
You're muted.
You're muted.
Sorry. I think we didn't finish discussing whether or not it's Kublet's job to enforce read access on these things. So where the current proposal is basically you name a trust anchor set via its signer name, and then you get the roots. And I was assuming that roots are generally not like trade secrets. But I can see it going either way. And I was curious if anyone else had opinions on whether or not Kubelet should check whether or not the pod, the pod service account has read access to the trust anchor set.
Kubelet seems like the wrong point to be enforcing that. Like if you wanted to keep pods from mounting in trust anchor sets, I think admission is the right time to do that. And I don't know that I would bake in something to block read access to what I think should generally be public record, or as public as the cluster is record. That seems like an opportunity for a custom admission check. Like if you wanted to do something weird to lock those down.
Okay.
I think I could buy the train of thought that if you can create pods on a cluster, you can read any trust anchor set on that cluster. It might be a reasonable thing, even if you don't explicitly have the permission. I'm thinking about like the Bootstrap RBAC policy. Like maybe the Bootstrap one wouldn't actually give anybody specifically access to this. It's you're basically just implying if you're allowed to create pods or not. I guess the kubelet would have it, but that's not what I mean by Bootstrap. Does that seem fair?
Yeah, I was thinking kubelet, like system node needs access to read these things. And maybe just nobody else has explicit access. Well, but everybody has implicit access then. So yeah, I'm not.
Well, everyone who can run workloads on the cluster, which is not always everyone. I mean,
yeah, I would think that read would be aggregated up to view, that anyone who has regular read permissions to the cluster would be able to view these as they're public.
View isn't usually bound cluster wide. I'm trying to remember if there are other cluster scoped resources in the view role. I don't think there are, but I might be wrong.
I don't think so. I mean, I know in OpenShift we bound view at cluster scope for particular aggregated roles, but yeah, not in the traditional sense. It's traditionally used in the namespace scope, so I wouldn't expect it to have cluster scope resources in it.
Yeah, which again, sort of like, I think the expectation is people who are writing pod specs for these are treating these as well-known names, not like browsing their cluster for like, what trust anchor sets do I have available?
That makes sense to me.
I think there's quite a few like open questions, right? Here near the end of the doc, like I think around like what we should or should not do in regards to like CRLs and various other bits. I think I didn't make comments on it. I think but I think we might want to go over some of those questions to see if folks have thoughts.
Okay.
You might want to put it in the pretty view, Rita, so that way it's easier to find the last section that was actually for that. Oh, sorry. So keep going. Going up almost, I think there's a bunch of questions for right above. Right there, risks and mitigation. So yeah, in terms of the scalability thing, I had made this a general comment. I figured the kubelet might just have like one single watch on all of the things and just one big cache, and you just when you ask for something, you just if it has it in the cache, it's like good. And if it doesn't, then let maybe that's
Yeah,
like we should be able
I
to
think so. I've talked to some people on the internal GK scalability team about this, and their opinion is if it is a resource which there are going to be like not that many per cluster, like we don't expect the number of trust anchor sets to scale with the size of the cluster. Instead, you might have like 6. And they don't change that frequently, then it's okay that every node is pulling them into a watch cache.
Yeah,
but we have
especially if
been,
they have the ability to list and watch them. So with config maps and secrets, global list and watch were actually problematic. We didn't want to let nodes do that. And so a lot of the contortions that we went through were not only for scale reasons, but also so that nodes could only be allowed to read the specific config maps and secrets for the pods they were running. So yeah, I think the scale issue is probably solved by a list watch, and the list watch is probably okay in this case if this isn't considered a confidential thing to prevent nodes from reading.
I think we discussed the next question about the weird RBAC integration. We decided not to do that. Security, and we've also discussed should kubelet attempt to enforce which workloads are allowed on particular trust anchor sets. We decided if we want this, then it needs to happen during admission. And we probably do not want it. Security, should an individual trust anchor sets designate an OCSP, oops, misspelled that, endpoint to check for certificate revocation, or should we require that URL to be embedded in the issued certificate? Yeah, so I think this is what you were mentioning about revocation, right, Mo? And it's kind of like down to the choice of inside the trust anchor set, do we tell workloads, hey, this is the OCSP URL you can go to check on revocation of certificates? Or do we require the standard but poorly supported, I think, X509 mechanism where you embed the revocation endpoint in the certificate? I don't have a strong opinion either way, except that I suspect that very few pieces of software would use a custom Kubernetes endpoint to like a custom Kubernetes integration to read an OCSP URL out of some Kubernetes object. Of course, also very few pieces of software will read it out of the certificate and use it. But I don't know.
Yeah, I wasn't sure if we could have the kubelet also read that out and stick it in some file or something, but then again, we get into the same situation of who's going to read the file and why.
Yeah.
I don't know. I think the two remaining problems I see with search stuff in Kubernetes generally is trust distribution and revocation. So obviously this handles the trust distribution part. I was just trying to see if we could also somehow have some story for revocation that wasn't.
So I think we have this sort of semi-public certificate issuance to workloads system. It backs a couple of different things in GKE, and we, like our production security people, ended up just telling us like, let's just make sure the certificates are, you know, live for no more than 24 hours. Because that's foolproof. And revocation is not.
I'd recommend we just start with the X599 extensions and see where we go from there.
Okay, I will need to read it. I know they exist. I will need to
Yeah.
read them and mention them in the.
Independent of this, like if we were going to do revocation, we should point to those in the extensions in the certificates themselves, not do a custom thing via this mechanism.
Okay.
Yeah.
For the last two, reliability, how can we safely canary a change to trust anchor sets object? This is a question from Matt Hildebrand. It's basically what he's asking is, so we're rotating, you know, the roots that back our signer, and like the current mechanism lets us add a new root and it gets propagated everywhere. So it's like possible to do the rotation safely, assuming none of our software freaks out and blows up because of the new root we added. He was wondering if it makes sense to be able to say, okay, my sign, here's V1 of my trust anchors for this signer. Here's V2. Now 1% of my workloads start using V2. Now 2% of my workloads start using V2, etc. Or some other equivalent canarying change. So we're not within the course of 5 minutes adding a new certificate to everybody in the cluster, and then when we're cleaning up the rotation within the course of 5 minutes, removing a certificate from everyone in the cluster. And I told him, yeah, that's a good question. I will put it in the doc.
So as a high level, you know, I could imagine one way you would try to do this is just on a separate environment, right? You first roll it out in a non-prod environment and watch stuff implodes on itself. But because this is like a cluster scoped intrinsic config, right? It's kind of hard to like mess around with. Also, I had this as a question just in general. There's no way for you to know that all of the clients that care about a particular trust anchor set have observed the change, right?
Correct. You would be able, we would have some metric probably from Kubelet that would say, yeah, now I'm writing the new one. But for the actual software inside the pod, it's kind of all bets are off.
I mean, that's an interesting point. So for like projected tokens, we just made client go and kubelet like rotate. We set a minimum bound of 10 minutes. Like you can't ask for one shorter than 10 minutes. And then we made the software we control that consumes those things start trying to rotate at like 70% of that time. So that's one way to do it. These are probably going to be slower moving. So rather than trying to bake like a progressive rollout approach into this API object and having like a, you know, current and next, or, you know, canary and current, or like trying to represent the rollout in this object, you could also just indicate how frequently you expect consumers to check back in or cache for. Like if we're expecting kubelets to be watching, like they're going to have updates. If they don't have network issues, they're going to have updates like order of, you know, milliseconds. But if a client isn't watching, like maybe it would be useful to have a hint in this object, like what's the GTL on this, like a DNS record or something. Like if I want to tell clients, like you have to check in at least every 24 hours. And then I, as the maintainer of this trust root, commit to like not removing the old root quicker than 24 hours after I introduce a new one, something like that. That's more like informational to say, like, if you're not actively watching and getting updates, then you need to not cache longer than this time. I don't know. That's one possibility that doesn't put a lot of complexity in this API, but gives consumers something to make a decision based on.
Yeah, I think maybe some of the complexity and rotation comes from once we smush, like, so this is just the trust anchor distribution. There's another kept coming that is about actually issuing the ability to issue certificates to pods. And then you have to be more careful because the rotation actually affects, like, you have to add the new root to the trust anchor set. Then you have to reissue all issued certificates, which you would typically do by just waiting for, you know, your 24-hour lifetimes of your certificates to expire and be reissued. So you wait 24 hours or 48 hours. And then, and maybe you confirm with kubelet metrics saying like, hey, which root? I don't know exactly how you would do that, but, and then you can remove the old certificate. Yeah.
Yeah, so there's life cycle built into that. It's like the 3-step thing, like add the new root, wait until you're sure everyone who cares has picked up the new root, then start issuing new ones, then wait until all the old ones have expired or have been reissued.
Yeah.
And then,
and I would think most people or most workloads will be pulling this through kubelet, so it would be pretty fast that they pick up the new root,
yeah.
or the removal of the old root.
But exposing it to the application is very different from actually reloading it. Like the current existing standard for here is how you set up a gRPC. Here's how you dial a gRPC expecting MTLS. Expects you to provide those at connection initiation, and then just lives forever, right? You don't rotate those. And
the
most
gRPC does actually, gRPC and Envoy have support for, here is a file on disk that may update. It contains my private key and my set of trusted roots.
But very few people actually use that code, as opposed to like the examples use the here's how you load.
In all the user stories for this, I just say, I configure certificate issuance, I configure trust anchor distribution, and then I make sure my workload checks every 5 minutes that the file on disk hasn't changed. And I kind of leave that up to you, the software engineer, understanding your stack. How do you do that?
Why wouldn't we just change the name of the trust anchor? V1, V2. That's what we would do for a config map.
Sure, I think we can.
New content into existing running applications so that long-lived applications can pick up the new roots without.
Yeah.
Yeah.
Kubelet would need to understand that convention.
What?
I said kubelet would need to understand that convention in order for it to make sense.
Why?
Because I don't want to have to restart every application in my cluster just because I'm canarying some new roots.
I think it's a choice to be made by the operator, right? So
I think you can do both, right? You can update in place, or you can make a new one and then redeploy with the new config and roll out that way. So I think we would want to support both mechanisms, right? We would not want you to, right? Like some environments and applications don't really care if you restart them, whereas other ones do. And so like,
Right.
so-
It's about the recommendation, yeah.
Yeah, we have a couple more items in our agenda, so time check real quick. Do we feel like we have at least enough to address some of the concerns raised in the PR?
I was gonna just make
And
one
this
comment. I'd seen comment in the chat about I'll just read it out. It says the problem with revocation distribution through extensions is that's very hard to change. Running a revocation list is a big commitment, while dropping a CRL file in a folder is not. So I don't know if that's maybe that's something to think about if we want to have a more simplistic mechanism for just saying that here's a, I don't know if you can, I forget what format CRLs are in, but maybe we could literally
Terrible X509 format.
Of course it is. Is it
there is a
XML or base64 encoded ASN?
But we repeat ourselves. It's an
Yeah.
X509 format.
Yeah. So maybe there is space in somewhere in this API for directly specifying a CRL file. I don't know, but maybe that's something to consider.
Okay, I've taken down some notes. I think I have enough to know what changes I need to make so far to have another reviewable version.
Great. And you know, we can always continue to discuss this on GitHub, or if you want to schedule a separate breakout session as well. All right, let's move on to the next item. I think it's this guy.
Yeah, there were a couple bugs that I ran across in the last few weeks. They weren't new in 124, but I think they're things we probably want to get addressed in 125. So this one is special. We actually set up RBAC rules that bind cluster admin to the super user group. So like in 99% of the time, this isn't an issue, but if there's something catastrophic happens, like hypothetically all the cluster roles and bindings get deleted and you're trying to, anyway, in extraordinary cases, you could actually run into trouble with this. And basically the authorizer we give to the admission chain to do authorization checks, like the CSR checks that Tahir was referring to, isn't actually the one that's wrapped with the super user special case authorization handler. So we have slightly different authorizers in two different parts of the API server, which is special. I think Mike left a comment. There's probably a quick fix, like moving the wrapping from API server config completion down into the authorizer construction. I think that's probably the right thing to do, but we want to add tests and make sure that we sweep for any other weird disconnects like that in the process. So if someone wants to jump on a pretty well-defined bug, I would be happy to have some help with this one.
What catastrophic thing happened to this user?
They were confused. They had a controller that was deleting things it should not have been deleting, and it deleted the cluster admin binding, which I said, oh, this doesn't actually matter. Like that's just there to like make visible the permissions the super user group has. They were like, no, it actually broke stuff. Like, no, it didn't. They're like, no, it did. And I said, no, it didn't. And they said, look, here it broke stuff. It's like, oh, man.
As an aside, do not write controllers that delete RBAC. It's just not a good idea. Unless you're like an RBAC manager, do not delete.
It was. That was the thing. It was. And it should be deleting the things it was managing, which would be fine. But anyway.
All right, fair.
like the fact that if you restart your API server, it reconciles that rollback. Like the recovery was not difficult, but also not obvious. And anyway, we should fix this. The next one, this was another thing I noticed trolling through Golang issues related to X509 stuff. We actually have a key usage specified in what we say is required for node serving certs. That doesn't make sense if the key is an elliptical key and not an RSA key. So we say you have to include this key encipherment key usage. This is what the CSR for one of these looks like, and that key usage doesn't make sense for non-RSA keys. So there's two steps to this. One is making sure that like any API validation isn't going to break if we relax this. The 3 steps. Make sure API validation isn't going to break if we relax this. I don't think there's anything at the API level that requires this. I think we're good there, but we need to check. Second step is making the controller, the signing controller that currently like really inspects the state of the CSRs to see what it should sign. Treat the key encipherment key usage as optional. And then once we've done both of those things, then on the requesting side, like we should only request this usage if we have RSA keys. There's been enough movement on the Go X509 side in the last few releases. It would not surprise me if at some point this starts getting rejected by validation. So I want to get ahead of things we are putting in X509 objects that are technically wrong or weird.
Why is it not allowed? Can you explain a situation where key usage would not be allowed?
I can't. I can link to discussions where people were saying that.
Okay.
Has anybody here read FIPS?
Has anyone what?
Here read FIPS recently. I could see FIPS including arguments or requirements around which flags are set or not set.
I read FIPS to my kids every night when I want them to go to sleep. I have not read it recently. At least
FIPS
on
covers
current
cryptographic modules, but it doesn't cover any X509 parsing or validation other than the cryptography. So I believe FIPS does not cover this.
Okay.
But yeah, maybe NIST 10.2.4.5.7.6. There's probably something that mentions this.
All right. Anyway, those are two. I'm trying to keep an eye on bugs that I think need to be resolved, so we actually make progress on some of them that seem like they could cause us trouble in the future.
Sounds good. Are these help wanted?
The first one was, they both should be. Neither one is a good first issue, but if someone's familiar with Cube, I think they're both pretty well scoped. I will add help wanted. Huh, neither one.
While you're there, Jordan, can you stick them into the right buckets in the swim lanes?
Yes.
I see Rita doing it.
Backlog, is that where this would be?
Yeah, I think so.
Okay.
We might at some point want to make a new swim lane for like things that we want to do more strongly than backlog.
I'm putting it in the milestone. I tend to use the milestone for that, like things that, and then that gives like a thing to filter down to, like SIG Auth, important stuff, SIG Auth stuff in 125. Like
Yeah, no, that's fair. The board does support milestone-based filtering, so that's a nice idea.
Yeah, if you think something's important, please add it to the milestone. Otherwise, backlog is just too much. It's like a black hole.
Right.
Right, should we move on to the next one? I think you added help wanted, so it's Tim, I think it's yours.
Yeah, so this is a feature request I filed a long time ago, and someone, blanking on his name, Sebastian, just picked it up recently and put out a kind of like an early draft cap. I guess the thing that I wanted to talk about here is whether this is actually something we want. So the idea was to have raw request and response recorded in the audit logs. So this is the actual request and response body that's received and sent by the API server. Motivations include, I think this was originally motivated by some CVEs that we dealt with around like billion laughs style attacks, YAML that expands infinitely, things like that. So catching that sort of bad actor request. Also for debugging or even kind of catching error cases, I guess that's debugging, but being able to identify when someone's attempting to set a field that is not recognized by the API server, since it just drops unknown fields. You could potentially do that by recording both the raw request and the interpreted kind of parsed request. I think those were the main two motivations. I can't remember what I was originally thinking about why we want the raw response. I think there's an opportunity to optimize that code so that if the response is JSON encoded, we don't need to serialize it twice. But I think that should be separate. So I guess the thing that I'm most interested in discussing here is, does recording the raw request actually seem useful?
For just a quick question, Tim, what exactly does it mean when you say raw request?
Basically writing out the bytes, maybe base 64 encoded if it's a binary format, from the request body.
And headers probably. And path, right?
There's already
Basically
there.
the full contents, right?
Path is already there. I think headers would be a separate discussion.
Is the normalized path there? Or is it the actual path? So I'm like, what about the one where there was a header injection in the Go library? So I guess for this to be useful, we would need to enable this request level, this log level on all APIs to, I guess, at least for your example, that accept YAML content type.
Yeah, that's a good point.
I guess in relation to like Mike's question, like could you do this purely in like our handler chain, or do you actually need to drop down a little bit to like maybe the connection? Like I'm curious if we're thinking about this as like after some things have been parsed but not all things, or is it truly like before any parsing has been done by the API server and you're getting basically the raw bytes that the client's in?
I mean, the request URL has raw path and raw query and raw fragment. So even though it's parsed into the request the request URL, it keeps the raw versions accessible. And
Does it have
then
raw-
our
does it have
API
raw
server,
headers?
what?
Does it have raw headers? Does that even matter? I don't know if that matters. I'm just asking for that line.
No. And then we are the ones that turn the bytes of the body into an object somehow.
I also
Mike,
have
your
doubts.
question about like if this would have helped catch like a Golang issue, like if the issue is in Golang, then the parsing is gonna be wrong, and the objects that we're populating this with are gonna be wrong, right? At least the smuggling, like the header smuggling issues.
Right. So maybe just for a billion laughs, to be useful, we need it on all APIs except content YAML. That's a lot of data. That also includes a lot of sensitive data that we would normally only log at metadata level, including secrets and token review. So
Yeah, it's a good point.
yeah.
Another issue is for this to be useful, we would actually have to write out a response stage or a log event stage before the request was actually parsed. Because if the request parsing is triggering
The panic.
the panic,
Right.
then you won't get the audit line. I think from a security standpoint, I'm not convinced that this is worthwhile. I think the follow-up question is, would it be useful from a debugging standpoint for capturing ignored fields?
So ignored fields actually complain super loudly now with server-side field validation. So duplicate and ignored unknown fields, there's capability built into the API server so that when those fields get dropped, it can return warnings and say like, hey, I'm dropping these fields. So
great.
Yeah.
Do you happen to know if we capture warnings in audit logs?
I don't know. I don't think so.
We not capture headers? I know this is outgoing headers, right?
No. Audit annotations are like the metadata and then the response body.
Mm-hmm.
But we don't capture headers, and I'm pretty sure we don't capture warnings, returned warnings specifically.
Mm-hmm. We may want to consider also writing audit annotations for those warnings in that case.
I'm not convinced about that.
Warnings are supposed to be for the client, right? Not necessarily the audit sync.
This kind of reminds me of, go ahead.
Oh, I was just going to say we explicitly separate those out in pod security.
Yeah.
But yeah, go ahead, Mike.
Targeting the user and then targeting the admin.
This the use case for debugging reminds me of the keylog writer, where somebody wanted to configure a keylog writer so that they could use TCP dump and the keylogs that we write to unencrypt a packet capture and just see the raw request that the API server is sending, something like Wireshark. Yeah, especially when we start talking about stuff like including warnings and stuff. I don't know. It seems like in the past we haven't made a great distinction between like request logs and audit logs, and we don't really have like request logs other than what the Kube API server logs. And we're kind of venturing into that when we start talking about including warnings and stuff, because we're going to greatly expand the size of audit logs that we write when we start including stuff that we think would be useful for debugging. So it might be useful to pursue the alternative.
Folks, we're at time. So Tim, do you think you have what you need to comment in the PR and the issue?
Yeah, I think I'm going to close this out. I'll summarize all the points we discussed here, unless anyone vehemently disagrees with that decision. Yeah, I'll close it out. Feel free to comment on the issue if you disagree.
All right.
And I guess we'll punt on pod security until next week.
Okay. Right. Thanks, everyone. Bye.